Okay guys, we're on section 2.5, section D. A global maximum is also called an absolute maximum. It names the largest range value over the entire domain. A local maximum is also called a relative maximum, and it gives the largest range value in a specified interval. An endpoint maximum can occur at an endpoint of the domain. And this is all the same if you replaced all the maximums with the word minimum. So if we're looking at this example, we've got domain and range of this function is going for all the x's and the y values. The x values, since there are arrows on the end going left and right, will represent anything, all real numbers, negative infinity to positive infinity. The y values are only going down to -4 and then everything above it. So it includes -4 all the way to infinity. For increasing, you're looking at the values of the function where x is going up. That happens when it hits this minimum here at -3 all the way to the value of 2. So it goes from -3 up to 2. Or from this point at 5, and even though it hits that axis at 7, it continues to go up beyond that point. So 5 to infinity. The values that the function is decreasing are the values from negative infinity all the way to the point where it turns at -3. So negative infinity to -3. It also happens to go from 2 to 5, where it's going down at those points. The min values and the max values, for looking at local maxes, that means everyone that's even in the middle of this function, a local max is over here at 2, -1, a high point in the middle of the graph. A local minimum is the point at which it's at its low points in the middle of the graph. So we've got the local minimums over here on the left is down here at -3, -4. Over here on the right, a minimum happens at 5, -2. And if we're looking at global minimums, since there are two local minimums, one of them is an absolute or a global minimum, and that happens at -3, -4. That happens to be the point that's the lowest on the entire graph. And if you're talking about global maximums, there's no highest point because the arrows go up on each end. The maximum is like infinity, so there's no point at which there's a max. The places where the intervals are greater than or equal to 0, the function is above the x-axis. That happens all the way from this intersection point on the x-axis at -5 to negative infinity. So negative infinity to -5. And it equals that point, so we put a bracket rather than a parenthesis. And then over here on the right side at 7, that's when it equals 0, all the way up to infinity when it's greater than 0 above the x-axis. The points at which f of x is less than 0, that happens for all the other points in the graph going from -5 all the way up to when x equals 7, not including them because that's when it's equal to it. So from -7 or -5 to +7, and you have parentheses. This function is not symmetrical over the y-axis or over the origin, so this is neither even or odd. The next one on your paper, if you want to take a look at this graph, has some points given to you and a function, so you may want to pause this, write this function down, and try it on your own, and then we'll go over the answers in class.